Hi, my name is John Paul Raj, and I'm on a mission to make the learning of math fun. So if you're new to this channel, please do consider subscribing. This is part 8 of transformations of functions. And on this video, I'm going to solve two different questions based on a certain suggested order for transformations of functions, especially when you have questions that involve combined transformations. And if you follow this technique, you will get your sketching of graphs right, even without the aid of a graphing calculator. Let's do it. Whenever we have questions that have more than one transformation, a combined set of transformations, we have already seen in an earlier video that the order of the transformations matters. So that's why a suggested order really helps. The first thing you must take care of is the reversing signs. If there's a reversal of sign from the parent function, take care of that first, okay? Reflections, whether it's a reflection about the x-axis or the y-axis. The second thing take care of is any stretch or compression, whether it's a stretch along the y-axis, stretch along the x-axis. That's the second thing to take care of. And only at the end, take care of any translations, whether it's a horizontal or a vertical translation. The two examples that we are going to consider in this video are as follows. The first, one at a time. H of x is given as -3, x plus 5 the whole square minus 4. First step is to always identify the parent function. Okay, so the parent function, that's going to be a first step. F of x is, in this case, you can see it's a square function. It's a quadratic. Okay, so let's just draw that. Okay, simultaneously right here on the side. So our parent function, a quadratic, and as we've seen in an earlier video, you need to know all your basic shapes. Okay, what the basic parent functions are, and the quadratic is one of the basic shapes. So this really helps. Okay, now the second step is to take into account any kind of reflection. Yes, there is some kind of a translation happening. That's a vertical translation going down by 4 units. There's a horizontal translation going left. And there's also a stretch here. But first, if there is a negative sign, all right, if there's a reversal, if there's a reflection, take care of that first. So what we're going to do is that just follow this suggested order religiously, like I said. So we're going to have y is equal to a negative f of x, and that is a reflection. Let me use another color, darker color, I mean, reflection about x-axis. Right? That's a reflection about the x-axis. So our graph now is going to become, because of this, it's a reflection about the x-axis. There we go. All right. So it's not artistic, as you can see, but it's going to give you some idea. That's going to y equals negative x squared. There you go. So, but it's going to give you some idea what the graph is going to be like. Okay. So that's what curve sketching is. Just make sure that you indicate the important points, the key points, if there are intercepts, and then you should be good to go. All right. The third thing to take care of is the stretch factor, and here we've got a vertical stretch of a factor of 3, all right, along the y-axis. So we have the graph becoming -3 f of x. Okay, f of x was the parent function. Okay, that's what parent function. The parent function got reflected about the x-axis, and now that 3, remember, it's not the -3. So the negative has already been reflected about the x-axis. The 3 indicates a stretch vertically along the y-axis by a factor of 3. So let's just write that thing also down. It's a stretch along y-axis by a factor of 3. All right, so it's that reflected graph. So let me just draw that graph now. Okay, so here we have, and it just becomes closer to the y-axis, as we saw in earlier videos. There you go. Right, and that we can call it as y is equal to -3 times x squared. So what has happened from x squared, it's got reflected, and now it's a -3 times x squared, stretched along the y-axis. And then finally, we can put our translation. As we saw that clearly, it was x plus 5. It was x plus 5. X plus 5 means it's x minus of -5, all right? X plus 5 the whole square minus 4. This is easier to identify, right? Because of the negative sign. This is kind of a little strange, okay? So that needs to be x minus of -5. For those of you who haven't seen that video of mine on translations, horizontal and vertical, take a note of that, okay? Go ahead. I'll link that video in the description box below. Go and take a look at that. This gives you h, the value of the horizontal translation. When it's negative, it's moving to the left, and k is -4. That means the vertical translation is going down. Okay, so this is my new function now. Y is equal to, remember we have the -3 here. And is that it? Is there anything else? I guess that's about it. Okay, so that completes the graph, and let's translate this graph now, which is reflected with that uh, vertical stretch also. Left by 5 units and down by 4 units to get the final position of the graph. Okay, so here we go. The final one should be -5 and -4. So let me just 1, 2, 3, 4, 5. Just an approximate idea. 1, 2, 3, 4. That should be -5. That should be -4. So somewhere down there, that's my coordinates of the new vertex. I can draw that graph. Okay, nice stretched. And there you go. There you can identify that point as -5, -4. And that should be the graph y is equal to -3x plus 5, the whole square minus 4. Can you see this? All right, now what do? Let's check that. Now this is what we've done, and we can do this without the graphing calculator. We're just using the graphing calculator to check what we've done is right or wrong. So I'm just going to enter as it was given. All right, so for negative, remember, use this key, -3 times open parentheses, you got x plus 5, and I'm just going to use the square, and we have a -4. There we go. And as we expected, there it is. Let's just quickly check these the coordinates of that vertex. Let's find the maximum, analyze that graph, coordinates of the maximum, and there we go. That's -5, -4. So what we've done is perfect. All right, so here we go. Let me just show it to you. That's right, okay? It, like I said, it's not artistic, but you've got the basic sketch. And if there were intercepts or, any other key points, then you got to mention those also. Let's do one thing, okay? This part, I want to just introduce a certain equation before we do the second one. This is your A, this is your K, and this is your H. Something else is missing here. In this case, it was 1. There's also a dilation, okay, a horizontal dilation. But in this graph, it is just 1. But a general form of this transformation equation, if you were to call it, is given something like this, okay? Here we go. I got this from some other textbook, okay? So f of x is A. F of x is equal to, it should have been written as y is equal to, right? Because then you've got f here and f here, right? So ignore that and make it y is equal to, okay? So let me rewrite as y is equal to A f of b x minus h plus k. All right, this is really helpful, okay, to see that. So all those different factors that influence the transformation of the graph is presented there. Here we go. A is what's going to give us the stretch factor, okay, the vertical stretch, okay. There we go. A is a vertical stretch, okay, stretch factor by A. In this case, the example that we saw, that was 3, okay. If the value of A, the absolute value of A is less than 1, it's a vertical compression, but again by a factor of A. The negative, we already saw, that takes care of a reflection in the x-axis that we had in this question. It was -3, okay. So that's about A. B, which we did not have in this particular question, okay. Sometimes you will have it, okay, or sometimes you have to manipulate it, and I'll show what I mean by that. So if that B is greater than 1, we have a horizontal compression, and this time, remember, it's 1 by B. So whether the absolute value of B is greater than 1 or whether the absolute value of B is less than 1, the compression factor or the stretch factor is 1 over B, and that affects the domain. And then we have H, as we've seen, all right? H is affecting the horizontal movement, H being positive, okay? It moves to the right horizontally. H being negative, it moves to the left horizontally. And that K, likewise, is affecting the translation. K being positive, the graph goes vertically up, and K being negative, the graph goes vertically down. What I meant by this B, what if you had a case something like this, so you had y is equal to a negative 3x minus 6 the whole square plus a 4, okay? It would be better that you first factor it to write it in this form, okay? That B is factored out, okay? So just watch what's happening, okay? So when you have 3x minus 6, it's better to write it as -2 3x minus 2 the whole square here plus a 4. All right, so now you can compare it in that form and say, okay, that's your A, that's your B, that's your H, and that's your K. Okay, write it in this form, even if it's given in this form, because so if it was a question where you are not allowed to use the graphing calculator, but you have to describe and not just make a sketch of the graph, then if you write it in this form, isolating the B, that means factoring out the B, not isolating the B, in this form, this form that I just introduced you to, y is equal to A f of b x minus h plus k. That really helps to identify what the different transformations are. So in this particular case, you know that yes, there is a reflection about the x-axis of this parent quadratic function. Reflection about the x-axis is happening. The new coordinates of the vertex are going to be 2, 4. Okay, 2 units to the right and 4 units up. There's going to be a vertical stretch by a factor of 2, and there's going to be a horizontal compression. Okay, that b is 3, and there's going to be a horizontal compression of factor 1/3. Okay, so be careful when you're indicating what the factor is, b, a horizontal compression or a vertical compression, whichever case you go to, by a factor of 1/3, whereas the vertical stretch is a factor of 2. And we already said, we've already seen the vertical shift or the horizontal shift. Now, because this 3 can be factored further out, this equation can still be written as y is equal to a negative, that 3 square can be written as 9. 9 times 2 is an 18, x minus 2 the whole square plus 4. You could still write it like that, but this is not going to work. Can you see this? This is not going to work for all functions. For a quadratic, it might work, but it's not going to work for all kinds of functions. So, I didn't want to talk about that, but some of you probably are wondering, why didn't we do that with the b, and therefore there's no sign of b in this case. Like in the earlier case, there's no sign of b. But if there was something like this, it's better to write it like this first, or like this. This is also the same graph. And let's verify, okay, that they both are the same graph. Let's verify it on our calculator, okay? So here we go. We're on the graphing calculator. I'm going to enter both the functions as they are. So why don't we do it on a new page maybe? All right, so here we go. New graph page. I'm going to enter the original one as it is. So -2 times, I'm going to enter that as 3x minus 6, okay? So 3x minus 6, the whole square. And we're going to put a plus 4. And when you hit enter, we see the graph there, and you can see that, okay, there's a vertical stretch, and we saw that it was reflected, and it is reflected, but the vertex has moved up to what did we say the vertex was? 2, 4, right? So let's check that also. The maximum value of this graph is 2, 4, as we saw. And let's see that 18, the negative 18. Let's see that it's the same graph. Okay, so I'm just going to go and enter it as a negative 18 times what was that? X minus 2. X minus 2, the whole square plus a 4. That was what the second graph was. And you can see that it just goes on top of that, which means they both are the same graph. Verified that these two graphs are the same algebraically, as you can see that. But more important for us was to be able to identify these a, b, h, k as in this given equation, just in case if you have a question where you have to describe without the use of the calculator, and you're supposed to describe what the transformations are. We've run out of time, so I won't be able to solve the other question on cosine, the transformation of the cosine function in this video, but I'm going to solve that in the next video. Don't miss that one.